trap system is one of the important elements in the evaluation of hydrocarbon. Identifying the trap system is much more important than identifying the DHI indicator and sand quality identification. So by applying the technique of multi-attribute, we can differentiate and eliminate the structural and the stratigraphic trap system in the subsurface.
Our interpretation process begins with the Petrel software. First of all, we load our seismic data, the Ledan Barat data, into the software, and we begin the interpretation with fault picking. After we have done picking the faults, we start with horizon picking for the top and bottom horizon. And after we've done with that, we generate a surface map of both horizons. Afterwards, we apply a few attributes, which are the RMS amplitude, the chaos attribute, instantaneous phase, instantaneous frequency, and envelope. By applying these attributes, these are the results that we got.
The first attribute that we decided to apply is variance attribute. We chose this attribute because it shows the stratigraphic of the area, and this attribute is widely used to detect structures such as faults and discontinuities. But in our case, this attribute only shows the unconformity within the area. From our seismic section, the bright orange part highlights the unconformity. This is the part that is highlighted by the variance attribute. To further verify the existence of the fault, we decided to go with chaos attribute. Chaos attribute is usually used to detect discontinuities and faults. By applying this attribute to our seismic section, the fault can be seen more clearly and it is highlighted with darker color.
Instantaneous phase is almost similar as variance and chaos attribute, but apart from the other two, instantaneous phase can highlight fault better. As we can see here, there are various faults that we have overlooked because it is not visibly present in the variance and chaos attribute, but it is much more clearer using the instantaneous phase attribute. Instantaneous energy, on the other hand, shows possible direct hydrocarbon indicators or DHI. This attribute also shows lithological change, and as we can see here, the layering is much more visible and much more clearer using this attribute. In this seismic section, we can observe in the circle area a darker colored anomaly, which could be a possible DHI. The DHI is bounded by the angular unconformity, so this could be a possible stratigraphic trap.
Envelope attribute, also known as the reflection strength. Envelope attribute is commonly used to highlight discontinuities, changes in lithologies, faults, and to detect dry spot in the subsurface layer. So by using the envelope attribute, we can observe an anomaly located within the layer, confirming that the presence of possible hydrocarbon in the layer located at the full wall of the lime green fault. As for the RMS amplitude attribute related to the porosity of the layers. As you can see in this picture, the bright red color indicate the high porosity. So if vice versa, light blue color indicate low porosity, which we can safely assume that the light blue color layer can be sealed for the trap.
In conclusion, variance attribute, chaos attribute, and instantaneous phase is used to detect the structure that we believe may act as a seal or trap to the reservoir. And instantaneous frequency and envelope is used to detect the DHI. And last but not least, the RMS amplitude is used to detect the porosity of the layers.